we found in a second class, that is pre-existing whatever derived material from the pre-existing rock, that is quartz. It's always the most abundant and certain accessory minerals such as certain uh, minerals such as we know that's zircon, rutile, tourmaline, garnet, and kyanite. And along with that, we see the magnesite also. The major mineralogical compositions in a sediment, it is affecting by the different factors. Sometimes it's a soluble of a residue of a rock decomposition. It's usually form the chief constituents like a clay, whereas sands, it's consisting of quartz and feldspars. The mineralogical compositions also is to depend on their nature of a rock. And the nature of a rock means how it is going to form and how it is gathering the ground material. Depend on that, it is going to form. If the country rock, it's consisting of a uniform of a mineral compositions like a quartzite or granite compositions. Or sometimes maybe it has a very poor composition of a magnesium, iron magnesium minerals. And sometimes it's participating in a denudation when it is going to be formed as a sedimentary formation. It is participating in a denudation form, and finally it is formed as a waste of a lithological material. It is a heterogeneous material. And then the duration of a nature, the transport, it's also very important factor to determining the mineralogical compositions. It is a long and continue drifting to and fro by wind, by water tends to affect the separation of particles according to the mass surface area. Here the example for panning and washing of a gold in other heavy constituents, it's a form from a sand or gravel. It's very effective for modes of sorting. The streaks and patches of a sand in rich garnet, magnetite, it is going to be found in some beaches. As an example for natural panning. The transport tend to destroy the softer, more cleavable and brittle mineral grains, and thus produce a greater mineral uniformity in a final material. And if you see the feldspars, these feldspars are the more altered and softer, and it's consequently it's more easily to break down into the smaller silt and clay grades. Sometimes the waves of a sea are more effective in eliminating the feldspars from sands. Other minerals may be similarly it's eliminated from sand. It is in a proportion to their softness and susceptibility to alteration and cleavageability. Textures. In a textures, it is referring to grain size and a grain to grain relationship. In a particular sedimentary rock textures, it is maybe divided into the clastic and non-clastic type. In a clastic textures, which are the characteristics of mechanically deposited, while non-clastics, those are characteristics rock deposit chemically and by the activity of organisms. Organic material will be formed in this one. This is a variation between the clastic and the non-clastic textures. In a clastic texture, the term clastic is applied texture to the texture of any rock its original fragmental characters, it is clearly visible. Textures and sedimentary rock includes mainly the grain size and the shape of a grains. It's playing a very important role. The grain size. The grain size of a sedimentary rock, it's depend on the mode of weathering. It's a mode of weathering, the texture and composition of a pre-existing rock, and the kind of amount, the transportation of a material, how it is transporting, and what is the amount of a material it is going to be transported from one to another. In the mode of weathering, it's a chiefly decomposition. The material it is produced is a floor-like fineness. That means like it's a floor material. The disintegration, it's producing the coarser grains because of when it's operating along the cleavages or around the margin or a coarser grain in a rock or along the joints and the fissures in a fine grain rocks. Therefore, the material it is produced, it has some same grains as the original rock, and size it is depending on the spacing of the joints and fissures. We know that the grain size it's depend. The size is it's depend on the amount of a transport material. If the continued transport is, it will be there in that one. Automatically, the grain size it is going to be reduced. The grain size it is going to become a smaller because of what it is behind that reason. If it is transporting continuously, then the big size of grain, the big size of a grain become a smaller because of the roughness of the surface, or the always it's rotating on the surface. It's moving one place to the another. It's moving on the surface, so that the angular phases it is going to be lost, and it's getting the roundness, and it's getting the roundness. The medium of a transport is also very important factor here. The medium of a transport is also very important. Either maybe it's a water or it is maybe a air or whatever. Air means wind, whatever. The grain transported by a wind, it is more wear to shear than those transported by a water. And so if we see the deposits are more fine grained. Depending on the sizes, the overall fabric of rock grains is differently be described as a boulder, cobble, pebble, gravel, pores, like that. You'll see that is. This is. You see here, depend on the sizes, the ranges of the sizes, the grade will be divided. If it is boulders, if you can see the under the boulder grade, the range of a size fragment, it's a greater than 200 mm. It's a cobbles. The cobbles between the grain size, it's a maximum. The range of size fragments, it's consisting of a 200 mm to the 50 mm. In examination, it will come under the match. Match the following questions will become from this one. Boulder, suppose the boulder, we can consider that is the size, it is more than 200 millimeters of a size. Cobbles, we see the cobbles, it is between the 200 to 50 mm size. Pebbles, the pebbles, it is 50 mm to 10 mm size. Gravels, it's also less than very, gravels it is from 10 to 2 mm size. Then coming to the sand type. The sand type here, According to that, the rock it is also, the grade it is also, again it has considered the group. Boulder, pebble, these two, these two, boulder and cobble, these two considered as a rhodites, or pebbles and gravel, it's considering as a gravel. The size it is, maybe it is from 10 to 50 mm, 2 mm to 10 mm. Very coarse sand, that is maybe 1 mm to the 2 mm. Very and next coarse sand. Coarse sand it is from 0.5 mm to 1 mm. Medium sand, that is considering as a 0.1 mm to 0.5 mm. Fine sand, that is 0.1 mm to 0.25 mm. Silt sand, that is 0.1 mm to 0.1 mm, 0.0, sorry, 0.01 mm to 1 mm. It is considered as a silt group. Here, the shape and the rounding of grains. The shape and the rounding of grains, the shape of clastic grains, it's depend on the original shape of material. It's supplied by the weathering and on the kind of transport. The quartz fragments, it is derived from the granite, and it's looking very sharply angular or irregular. Then we see the feldspar grains, it will be parallel cleavages. The fractures and the micas will be irregular flakes. Fine grained rocks are normally gives rise to the angular fragments because they determined by the fissure in a rock. So that the kind and extent of a transportation, it's playing the very important influence on the shape of a grains. The grains which are initially angular become a smooth and roundness depend on their transportation. Yes, definitely. If it is the transportation, if it is continuously, then automatically the sharp edges, whatever it has, then it is going to become a round and smooth surfaces. As per that roundness, the grain maybe it is described as a angular, subangular, and rounded and well-rounded. That is a depend on the transportation of a material and transportation of a material, and finally the distance is also playing the very important role. And how we can sort out. The another aspect, it is a clastic sediments. It is sorting. The most of the agents for transport tend to sort the grains according to their sizes, shape, and density. The sediments, it's showing the number of grains. Grain sizes are said to be an unsorted or ill-sorted graded. Glaciers which are produces the ill-assorted sediment. In other way, the wind and water produces well-sorted sediment. Non-clastic textures. In a non-clastic textures, the factors which are considered under clastic do not straight away apply to the non-clastic structures. Here, the roundness of the grains. In this case, the clastic grains means it's a wear and tear, which is they subjected during the transportation. In a non-clastic material were transported in solution and precipitated subsequently. Here we will use the term it's a roundness has a no application here. Because of the non-clastic texture, it's a producing the by one or more following process. That's the direct crystallization of inorganic reaction. Second one, crystal growth. Third one, replacement during the silicification or dolomitation. A typical non-clastic texture, it's a consisting the interlocking of crystals. When it's no intergranular spaces, such texture, it is known as a crystalline granular. In most of the chemical sediments, recrystallization it's taking place, at least partially due to the deep burial and the consequent increases the temperature and the pressure. Then the texture, it's maybe the crystalloblastic texture. In non-crystallizing texture, it is consisting the grain which are visible. Yeah. Yes, really. It's a non-crystalline texture, which are visible with the naked eye. They may it's divide into the, we know that the quartz grain, maybe the quartz grain it is greater than 5 mm, and second one it is medium grain. The grain size it is from 1 to 5 mm, and fine grain it is less than 1 mm. Some of the important textures here mentioned: amorphous, volytic, piezolitic, spherulitic, saccharohedral, and porphyroblastic. In amorphous, particles commonly of a clay size are colloided in a size. In a volytic structure, if you go into the volytic structure composed of a small spheres of ellipsoidal aggregates 0.25 to 2.0 mm diameter. The oolites show the concentric radial structure. It has internally radial structure. And piezolitic, it's very similar to the oolitic, but diameter it is more than 2 mm here. Yeah, spherulitic, the spheres which are with radiating internal structure. Saccharoidal, here it has a fine and equigranular. Porphyroblastic, large crystals embedded in a fine-grained matrix. There is a one property that is the cohesion. In all the sedimentary rocks are initially it's loose, the soft, but they have become very hard, and it's a compact of a course of a time. And it is happened by the two processes. One, it is welding, and or second one, it is a cementation. Yeah, the welding, it is involving the influence of a pressure due to the weight and superincumbent material or earth movements. So that the rock it is becoming very compacting within a pressure. Second priority, if you see, that is the cementation. The grains or particles are bound together by the cementing material, by the cementing substances. It is maybe a siliceous or calcareous or ferruginous or argillaceous material. Next, coming to the structures. Here, the structures in a sedimentary rocks, it's broadly it is divided into the three structures. One, it is a physical structure. Second one, it is a chemical structure. Third one, it is an organic structure. In a physical structure, it's a bedding. The most one, it is a bedding. It's a very important primary structure. We can able to identify in a sedimentary rocks. It's forming as a layering. The layers we are calling that is a strata or lamina, and which are resulting in a bedding in the formation of a stratification or a lamination. A stratum, it is an individual layer of a rock more than 1 centimeter of thickness. The lamina, it's similar to the stratum, but it's the thickness it is less than 1 centimeter. Here the differentiation between them. The stratum, the layer of a rock formation, it is thickness. It's having 1 centimeter above. the same thickness or the same formation, if we can see, it is less than of 1 centimeter. 1 centimeter. It is called as a lamina. The stratum or a lamina. It's appear very distinctly different due to changes in internal chemical composition texture. The surface it separates two layers. The two layers. It separates the two layers. That is called as a bedding plane. Some sedimentary rocks or deposits are non-bedded, such as a glacial till and loess. And fine bedded deposits may get destroyed due to the later effects. The sedimentary rocks where they lack bedding may give its rise massive sedimentary rock formations of a homogeneous nature it has. And there are various types of bedding structures we see. That's cross bedding, or sometimes we are calling that's a current bedding and torrential bedding. In graded bedding, the textural sequences, the grains, how they are having the textural sequences, it's arranged in individual beds, which grade from coarse at the bottom and top layer it has occupied by the finer pigment. According to the graded here, the big size of boulders, like example for boulders or cobblers or the pebbles, and these are all the settled down in a bottom space of the bed. But when you come into the towards of top, and the fine material was settled down. So according to the grade wise, according to the grade wise, the beds are arranged. So this type of bedding, it is called as a graded bedding. When we go into the cross beds, we go into the cross beddings. It's a very common feature in the structure. What's happening here? When it is arrangement of these grains in a bedding, due to this is a current flowing, or due to the velocity of velocity, the direction it is going to be changes when the transporting of agents. Then the irregular type of a shape, irregular type of a structure, it is going to form in that one. That type of a structure or that type of a bedding is known as a cross bedding. The minor bedding planes, it is indicating the condition or changes in the velocity and the direction of a current also. Yet tabular, lenticular, wedge shaped, these are also there in a current bedding. Commonly, the major bedding planes are parallel with the subsidiary bedding planes. Bedding planes, when it's running in a different directions, it's called as a tabular. And second one, it is lenticular. These layers show the extreme irregularities in a shape and deposition. The major bedding planes may intersect with each other at different angles. Wedge shape. The structure, it is more complex, and its origin, it is still subjected to the controversy. So that the bedding planes of different sets dip in different directions and placed in different angles. And final one, it is torrential bedding. In a torrential bedding, it is succession of a graded beds. Here, the coarse and fine material, it is arranged alternatively. It's arranged alternatively. It's found in a alluvial fans or sometimes in a semi-region of areas because of the seasonal variations will be impacting on this one. So that the grain sizes which are arranged in the alternative. Yeah, the bedding planes sometimes maybe we can identify in irregularities and markings. The bedding planes of some sediments are characterized by some minor structures such as ripple marks, striations, and grooves. Ripple marks. The various types of ripple marks. That means the different patterns of ripple marks were developed in sedimentary because of the water waves and water currents or when wind currents will be working or will be impacting on the sedimentary formations when the sediments which are transporting into the diagenesis process and which is indicating the paleocurrent directions. The ripple marks are more commonly seen, particularly we can see in a sandstone, and than in argillaceous rock, which the currents flowing over the bed of a sand, it reaches a certain velocity by which the sand particles tend to give rise away wavy appearance. It's showing the wavy appearance on the surface of a sandstone. This type of wavy surface appearance, it is known as ripple marks. And broadly, ripple marks are two types. Symmetrical ripple marks, it's produced by the wind action. And second one, it is asymmetrical ripple marks, it's produced by the water action. And the another one, it is ripple marks, which are a formation. We can distinguish from the ripple marks index by the concentration of a coarse grain and at a crust and troughs. The ripple marks, it's formed by the wind. It consists of coarse particles and grains at the crest and the troughs. We may identify the mud cracks also. The mud cracks, these are particular features in sedimentary rocks. It's exhibited by the argillaceous type. Particularly these type of mud cracks we can able to identify in a argillaceous rocks. These will be formed in all colloidal sediments which are shrink and drying closer to each other due to the evaporation of water due to the sun heat. Those cracks of a polygonal shape which are developed in a soft sediments which are known as a mud cracks or sun cracks. The formation of a mud cracks, it's depend upon the original porosity or water content of the mud, the amount and the kind of clay minerals present and the thickness and the homogeneity of the mud. The other markings, other than those produced by the current, which are also we can see in a sedimentary formations. These markings are tracks and trails of animals and raindrops of and hail points. Sometimes we see the impression of salt ice crystals also. The raindrop and the hail impressions are very small, circular to elliptical pits, which are formed on the bed muds. The conditions, some conditions also it's required for a preservation of markings. It's a fine grained rocks of argillaceous type. And second one, it is sediments must be damp, but generally saturated with the water. Here we see the chemical structures. In a chemical action, the sedimentary rock it is responsible for various sedimentary structures. These structures are we can say concretions, secretions, and geodes. The concretions, the term of a concretion is used loosely for a variety or more or less rounded bodies and chiefly inorganic origin. It's occurring in all sedimentary rocks. The concretions are masses of a different chemical and mineralogical compositions than their enclosing rock. They are generally spherical, spheroidal, which are seen in a disc shaped also. These concretions are concentric around the nucleus. The nucleus, maybe it's having a fossil and inorganic fragments also. And these are all when you see it is a size available in small pellets like objects, the great spheroidal bodies of many feet in a diameters. Sometimes they are maybe in the homogeneous composition, and generally it's consisting more or less impure of silica, calcite, and other iron-oriented material. And next one, it is a secretions. These are formed within the empty cavities. These are formed within the empty cavities in a rock by percolating of a solution. The cavity maybe it's a completely partially filled by the mineral matter, usually in the form of crystals. Usually in the form of crystals. Sometimes it is leaving the empty space. The empty space, it is useful for a deposition. It is known as a wing. Another one, it is a druce. The druce, it's cavity lines with the minerals identified with those of the enclosing rock. Sometimes the secreted material is readily separated as a geode. The importance of a geode. There is subspherical shape and it has a hollow interior. The outer layer, it has a chalcedony. The inner lining inward, it's projecting the crystals. The evidence of a growth by expansion, and maybe it is vary in size, inch or a foot, or sometimes maybe it is appear in diameters. And final, when it is organic structure. There are mainly it's formed in a sedimentary rock, both in activities of organisms. There are two important structures in this. Those are biohemps and biostroms. The dome are biconvex like a structure. It is known as a biohem. Coral reefs are a best example for biohemps. Yeah, in a bedding like a strata, the structures it is formed by the organisms. It's called as biostroms. These biostroms are formed with corals or algal activity. coral reefs are very common. There are three important types of this one. Those are fringing reefs, barrier reefs, and atolls. Yeah. The classification of a sedimentary rocks. We see here, it's a classification of a sedimentary rocks. It's based on the formations. It's classified into the clastic and non-clastic as per deposition, in particular environment, and the availability of rocks and availability of grain sizes and availability of chemical organic rocks, and depend on the grain sizes. And the maximum these type of rocks are it's made up of the different fragments of minerals or different rock matter. It's produced by the mechanical action and mechanical action of the agents of a denudation like wind, water, glacier. Depend on the size of a grains. It is divided into the rhydaceous rocks or rhyodites, or arenaceous rocks or arenites, and argillaceous rocks or lutites, we are calling that is. Yeah, the clastic rocks you see here, the sedimentary rocks, it's divided into the two parts. One, it is a clastic rock. Second one, it is a non-clastic rock. In a clastic rocks, that is again, it's classified into the three types. One, rhydaceous. Second one, it is arenaceous. Third one is argillaceous. If you go into the non-clastics, and the non-clastic depend on the availability of chemical deposits and depend on the organisms. It's divided into the two types. One, it is a chemical deposit. Second one, it is organic deposits. Again, we come into the formation of rhydaceous rocks, availability of fragment sizes, and that is divided into the boulders, cobbles, pebbles, gravels. Depending on the grain size, it is divided. The similar if you come into the non-clastics of chemical deposits, it is divided as siliceous deposits, carbonate deposits, ferruginous deposits, phosphatic deposits, and evaporite deposits or evaporates. Or we see in organic deposits. In organic deposits, it's dividing as calcareous, phosphatic, ferruginous, siliceous, and carbonaceous deposits. Actually, this group, it is partially, it has a chemical and a mineralogical compositions. Mineralogical compositions. It is from the rhydaceous to up to argillaceous rocks. And slowly it is going to be increasing. The definite chemical composition and mineral composition will be traced. The pebbles and boulders in a rock formation, mostly it has a heterogeneous group, or we consider it is a heterogeneous group. Then in arenaceous rocks, the composition mostly it has a quartz with subordinate of feldspars. That's necessary and highly, these are all highly siliceous. When you go into the argillaceous, with the comprise of the finest product of a rocky material, product of a rock decay, and especially it is decomposition, or consequently it's made up of consisting of a hydrous alumina silicate. Silt rocks are intermediate in a composition between the arenaceous and argillaceous groups. The composition may be different between wide limits. Even in the argillaceous group, rocks it divides of hydrous silicates may occur as the best example for detrital limestone and mud material. Yeah, in another group of sedimentary rocks, the agents are the most prominent in producing their present characteristics. Suppose if it is in water formed, that is maybe in aqueous aeolian, it's from coming from the uh, wind, glaciers, it's coming from the ice formed or snow. And along with this one, the marine deposits will be also there. And it's marine deposits along with the continental fluvialate, eastern, lacustrine. These are all from the marine deposits. And coming to the radiaceous rocks. In a radiaceous rocks, maximum these rocks, it's consisting of 50% of fragments. It's looking into large size. Always it's more than a 2 mm size. The grain size in this group, it's classified as a boulder. We know that the boulder, the size, it is above 200 mm size. And second one, it is a cobble. The cobble size, it's from reduced from 200 to 50 mm size. And third one, it is pebbles. Pebbles, that's also reduced from the 50 to 10 mm. Gravels, it's 10 to 2 mm sizes. These are the four basic size formations. One, it is a boulder, that is a having the size, grain size above the 200 mm size. Second one is a cobble, that's a 200 to or 50 mm size. And pebble, that is a 50 to 10 mm. Gravel, that is a 10 to 2 mm size. And these grains are cemented, cemented form. It is we can see in the cemented form as a conglomerator or in the form of breccia. The fundamental distinction between the angular and rounded fragments, it's depending on the amount of transport, the material, how it is going to be formed. Particularly if you can see in the breccia, the material it is suffered lesser, no transport, so that we can able to see this. It is in a triangular shape of a fragments. Or the same property if you can see in a conglomerate. The fragments of a material which is transported to the from one place to the another place, it's very long. Yeah, next one it's a breccia. In a breccia, it has a huge accumulation. Talus, scree, or occurs. It's a basis of a slopes. It's a settle down on the slope basis. The material in a breccia looks fresh and sharply angular formation, and these are often grooved, scratched, and shattered. In subtropical regions, deserts, polar regions, the weathering occurs mainly due to the physical disintegration. But there is no changes in a material. Uh, and it has a very compact material from one grain to the another grain. The cementing material will also there, and it's compacting very closely. Example, if you can see into the volcanic breccia, it is called as an agglomerate. It's a composed of a very important material as igneous substances, but it may sometimes it's consisting of a non-volcanic fragments also. These will be brought up from the basement of the volcano, and it's turned from the sides of the volcano material. And second one, it is a conglomerate. In a conglomerate, it's consisting of more durable fragments. It's by reason it's by their hardness, toughness have been enabled to survive the vicissitude, but because of it's a transported material, it's having the long distance transport, so that if it is looking to the rounded shape. Yeah, the loose radiaceous deposits with the rounded fragments are described as gravel, pebble beds, or shingle. The gravel say maximum it consists of a more or less rounded fragments of a diameter, maybe that is a 2 to 10 millimeters, and pebble beds and single material. It's a larger, ranging up to 50 mm size, or sometimes maybe it is a 2 inches